Welcome to Ask and Learn.
We're given a non-deterministic finite-state automaton, and we are asked to find a deterministic finite-state automaton that recognizes the same language as the non-deterministic machine does. So the non-deterministic machine is the one from exercise 46 of this section. In that exercise, we found that the language recognized by the machine was the set 1, 0, 0, 1, 0, 1, star, union with 1, 0, 1, 1, or 0, 0, 1, 0, 1, 1, star, Now, we saw in the previous exercise, the graph is actually almost deterministic. If you look at the graph from the exercise, you'll see that it almost doesn't contain any multiple arrows. So this should be an easy problem. So, first of all, we still have that state S0 is a start state. And of course, S0 will be a final state, since the empty string should be recognized. Now, suppose that the first bit in the string is a 0. Well, zero should not be recognized, and S0 is already a final state, so we should move from S0 to a non-final state, S3. And this way I'm trying to mimic the non-deterministic graph with the states I'm using. Now, once we're at S3, we should never leave this state again, because the string can never be recognized after this point. So we're going to remain at S3 for any input. Okay, so now suppose that the first bit is a 1. Then, just as in the non-deterministic graph, we should move from state S0 to a state S1, and we see that 1 should be recognized, so S1 will be a final state. Now, suppose that the next bit is a 1. Well, we see that if this is the case, then this string will not be recognized, should not be recognized, and in fact, any string derived from this string could never be recognized. So, suppose that the next bit is a 1, then we'll want to move to a non-final state S3 again. And once again, we'll be remaining at S3 for any other input. Now on the other hand, suppose that the second input is a 0. Then the string 1, 0 should not be recognized, so we should move to a non-final state. However, this should not be the non-final state S3 because it is possible that our bit could be followed by another 0 and then a 1, in which case the string should be recognized. So we need to be able to escape this non-final state, and so we'll call this a new non-final state S2. And of course, once we're at S2, it doesn't matter what bit we have next, whether it's a 0 or a 1, the resulting string should be accepted. So we'll move to S0 for either input after this. So if the third bit is a 0 or a 1, so this will give us 1, 0, 0 or 1, 0, 1. And we see that this is actually going to create a cycle